Before you begin, make sure you have a pencil and a calculator. If you do not, press pause and go get them now. Okay, let's get started with the next section, 6.2, solving multi-step inequalities. By the end of today, you should be able to solve multi-step inequalities. Remember that solving one-step inequalities is very similar to solving one-step equations. Well, solving multi-step inequalities is just like solving multi-step equations. The one difference is that if you multiply or divide by a negative number, you need to remember to flip your sign. Now, when we say flip, that means change the direction. You're not going to change the meaning of the sign or equal to, adding that bar, but you're going to change direction. All right, so let's look at number 1. We know that our problem splits in half through the inequality, and you always want to get rid of addition and subtraction first. Since we're subtracting 7, we're going to add 7 to both sides. The 7's go away. We're left with 4x is less than 20. Then we're going to divide both sides by 4. And here, when we divide by 4, x is less than 5. So this is our answer. And what we're saying is that any number less than 5 can be a solution to this inequality. So now we're going to graph that. Now, remember to plot 5, 1, 2, 3, 4, 5, that it's an open circle on 5, and we want to represent numbers that are less than 5. So there we go, there's our graph. So any number that we would pick in this shaded region would be a solution to our inequality. Okay, let's look at number 2. Let's change the color. All right, number 2. So here's where our problem splits. And you always want to get rid of addition or subtraction first. So here I have a positive 3. So I'm going to subtract the 3 because 3 minus 3 is 0. So I've got to do that on the other side as well. When those go away, we're left with negative 2x, which is greater than 5 minus 3, which is 2. All right, the next thing I need to do, and I'm going to change the color because this is important, is we need to divide. And when we divide, we're dividing by a negative. So this is that key thing that we're going to flip the sign. Oops, flip the sign. That's what that tells us. So in my next step, I can write that. Red. All right, so x is now less than negative 1. And then that is your solution. And if we go ahead and graph that, we have an open dot at negative 1, and we want to represent all values less than negative 1. All right, let's go to number 3. So here on number 3, we have a little bit more involved. Again, we have our problem split in half. Now remember, we have to get our variables on the same side of the equation. So you can choose to move your number terms first, those are constant terms, or your variable terms. So let's go ahead and I'm going to choose to add 2 to both sides of my equation first. When I do that, I get 3x is greater than or equal to 7x minus 8. Now it's important that I bring the 7x over to the other side. Since it's a positive 7x, we subtract 7x. 3x minus 7x is 4x, which is greater than or equal to negative 8. The last thing we do is divide by 4. 4's go away. X is greater than or equal to negative 8 divided by 4, which is negative 2. So our answer is x is greater than or equal to negative 2. And if we graph that, negative 2 is right here. We have a closed dot, and we want to represent numbers that are greater than or equal to -2. All right, let's go ahead and move on to example 4. Again, my problem is split down the middle, and I want to get my variables on the same side. First, I'm going to add 3 to both sides. And when I do that, I get x is less than 2x plus 4. And we're going to get the x to the other side. We're going to subtract the 2x. And those terms cancel. 1x minus 2x is a negative x, which is less than 4. But remember, you don't want a negative x. So to get rid of that negative, we divide both sides by -1. Again, here we are. We're dividing by a negative. Dividing by a negative. So if we divide by a negative, you have to remember to flip the sign. And then there we go, there's our solution. So now we plot it, -4, 1, 2, 3, 4. It's an open dot on -4, and we want to represent numbers that are bigger than -4. Okay, now we're on problem number 5. So in problem number 5, we've got a little bit more involved. You have to distribute. So let's go ahead and distribute the 3 into our set of parentheses. And when we do that, we get 6x plus 3 is less than or equal to 3x plus 6. Now, just like we did in the last problem, we want to get our variables on the same side. So I'm going to subtract 3x from both sides so that my x terms will be on the left. So 6x minus 3x is 3x plus 3 is less than or equal to 6. Now we're going to choose to subtract 3 from both sides. And we're left with 3x is less than or equal to 3. And the last step is to divide both sides by 3. So we are left with x is less than or equal to 1. And that is your answer. So we go to 1, we have a closed dot, and we want to represent numbers that are less than. Alright, in the next example, it's very similar to the one we just did. So let's go ahead. First thing you're going to need to do is distribute. So we say 2 times x, which is 2x, and then we say 2 times -1, which is -2, and we write down the rest of the problem. Now we need to get our variables on the same side. So I'm going to subtract this 2x from both sides. And when I do that, we're left with -2 is greater than 2x plus 6. But now the idea is to get x by itself, so I have to subtract 6 from both sides. And when we do that, -2 minus 6 is -8, which is greater than 2x. And then the last step is to divide both sides by 2. So we get -4 is greater than x. Now, with this answer, remember that it is important to rewrite this with your variable first. So if I rewrite this, my x comes first. Notice here I'm pointing towards the x. So when I rewrite it, I want to stay pointing towards the x. And then I write down my number. So this is what we want to graph. X is less than -4. Alright, so -4, 1, 2, 3, 4. We have an open dot, and we want to represent numbers less than -4. Okay, let's go down to number 7. Wow, in number 7, we actually have to distribute twice. So here we're working with more simplifying. Okay, let's go ahead. I'm going to use a green this time. Okay, so if I distribute, I get 3 times 2x, which is 6x. 3 times a positive 9 is a positive 27, which is less than 4 times x, which is 4x, and 4 times 2, which is a positive 8. Now we're going to go ahead and get our variables on the same side. So I'm going to go ahead and subtract 4x from both sides. And when we do that, 6x minus 4x is 2x, plus 27 is less than 8. Now to get x by itself, we're going to go ahead and we're going to add 27 to both sides. And when we do that, we are left with 2x, which is less than 8 plus 27 is 35. Right, so I'm going to go ahead and scroll down. Alright, so now to solve for x, we need to divide both sides by 2. If I divide both sides by 2, we get that x is less than 35 over 2, which you can leave as 35 over 2, or when you go to graph it, it's easier to write a fraction as a decimal for graphing purposes. So half of 35 over 2 would be, it would be 17 and a half. So it's less than 17.5. So if we go to graph this, now notice on my increments, this is really a bad number line. So let's go ahead, let's make our own. So here's my number line. I need to have a 0 somewhere, so here's 0. And I know that 17.5 is positive, so that's somewhere on the right. I'm going to go ahead and plot it. I have an open dot on 17.5, and we need to represent numbers that are less than 17.5. Now feel free that if you ever feel that the number line that's given to you in class doesn't work the way you want it to, then you can feel free to draw your own number line. Okay, before we get started on what this page actually says, I want you guys to know that there is a mistake. There is a mistake. And the mistake is in one of the problems in number 1 through 7. It is one mistake. If you can find the mistake and correct it, then you can have 5 points extra credit towards your grade. So 5 points extra credit for correcting the mistake. So I ran out of room, so we're going to stop there. So again, there's one mistake in one of the problems, 1 through 7. I'm not going to tell you which problem. If you can find the mistake and correct the mistake, you will get 5 points extra credit for doing that. Okay, so now let's actually take a look at what this page says. You're going to press pause and do numbers 8, 9, and 10. And when you are finished, check your answers with an adult in the room. If there are any mistakes, you will need to make corrections. Once you get 100% on this practice, ask for your homework.